This is Mr. Martin. These are the video notes for Precalculus Honors. This is section 8.1. This is video number 2. So in video number 1 we talked a little bit about recursive sequence and where the next term of the sequence uses the previous terms in the sequence. So the Fibonacci sequence is one of the most popular recursive sequences. Let's take a look at it. It says that a sub k is equal to a sub k minus 2 plus a sub k minus 1. So each term is generating by adding the two previous terms. Alright, and we define the 0 term to be 1, and we also define the first term to be 1. Okay, so then a sub 2 would be a sub 0 plus a sub 1. A sub 0 is 1 and a sub 1 is 1. So the second term is 2. Let's generate a few more. A sub 3 would be a sub 1 plus a sub 2. So the first term, the a sub 1 was 1. And a sub 2 was 2, so that gives us 3. And the fourth term would be the second term plus the third term, so the two terms right before it. So that would be 2 plus 3, which is 5. Let's do one more. A sub 5 is going to be a sub 3 plus a sub 4. So that's going to be 3 plus 5, which is 8. So we can see, let's add these in there too, that our sequence then becomes 1, 1, 2. So we're adding these two together to get the third one, and then the second and the third to get the fourth, which is 3, 5, 8. If we want to generate a few more, so 5 and 8 is 13. 8 and 13 is 21. Let's do one more. 13 and 21 is 34, and this would continue on. So that's the Fibonacci sequence. Let's take a look at this on the calculator. So in order to look at a sequence on the calculator, one of the ways is to change your mode to sequence. Okay, so go ahead and take out your calculator and hit the mode button and hit change it to sequence. And then when you go to y equals, you're going to notice some different things there. So for this one, we want to set our n min to 0. And then for u sub n, we want to make this u sub n minus 1 plus u sub n minus 2. So these are the two previous terms. And we want to change our u sub n min to be 1, 1. Now, if you just enter 1, 1, it should put in the braces for you. And then one more thing before we go to look at the table. If you go to your table set, you want to change your table start to 1, and then your delta table also to 1. And then if you go and look at the table, you should see that we've got n, and we've got values of u sub n. So we've got 0, 1, 2, 3, 4. This will continue, and you'll see you have 1, 1, 2, 3, 5, and you can keep scrolling down to take a look at those. Alright, so as usual, if you have questions, make sure you pause the video and ask those. Next, let's take a look at factorial notation. So you should have done this at some point in one of your other math classes. But if you haven't, again, just get the help that you need. So when we see this factorial, it's not n being very excited because it's an exclamation mark. It's actually factorial, and we read it as n factorial. So what this says is to take the number n and multiply it by all the integers, all the positive integers less than it all the way down to 1. So the number that's 1 less than this would be n minus 1. And the number that's 1 less than n minus 1, so n minus 1 minus 1 is n minus 2. And the number that's 1 less than n minus 2 is n minus 2 minus 1, so that's n minus 3. And then we're going to keep going all the way until we get down to 3 times 2 times 1. Okay, so you take the number and you multiply it by all the numbers, all the positive integers less than it down to 1. So if n was 10, it would be 10 times 9 times 8 times 7 times 6 all the way down to times 3 times 2 times 1. Okay, and then we have this special case. We just define 0 factorial to be 1, so keep that in mind. Remember this. Okay, so 0 factorial is 1. So let's take a look at a few examples that use factorial. So we've got 9 factorial divided by 3 factorial times 7 factorial. So 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then since we've got all multiplication, we can cancel some things out. I've got a 7 times 6 all the way down to 1, and a 7 times 6 all the way down to 1 here. So those would cancel. I can cancel this 3 with that 9, and that becomes a 3, and that 2 with that 8, and that becomes a 4. So then the only thing I have left is 3 times 4, which becomes 12. Now, if I was going to work on this problem, instead of writing out all of these, I probably would do 9 times 8 times 7 factorial over 3 times 2 times 1 times 7 factorial, just to make it a little quicker. And then I could do the same canceling here. All of these crossouts here are the same as 7 factorials. And then again, I could do these 3, and that would be a 4. And again, I still get 12. Okay, so that's a number example. Let's take a look at this with an expression. So I've got n plus 1 factorial divided by n factorial. So n plus 1 factorial is going to be n plus 1 times, so n plus 1, 1 less than that, n plus 1 minus 1 is n. And then 1 less than that is n minus 1. And 1 less than that, n minus 1 minus 1 is n minus 2. And I'm going to keep multiplying until I get down to 3 times 2 times 1. Alright, and then n factorial is n times 1 less than that, n minus 1. 1 less than that, n minus 2. And again, I'm going to keep multiplying until I get all the way down to 3 times 2 times 1. I can see that in the numerator, I have all of this. In the denominator, I have all of this, so that all that's going to cancel. And I'm left with n plus 1.